Good afternoon. My name is Eric Duran, and I'm the current president of the University of Dayton IISE chapter. So over the summer, I had my first engineering internship, and in this engineering internship, I got plenty of experience. And one of the best experiences I got was my first project. And that first project had to deal with material handling. And this material handling project was designing and then eventually buying a work in progress cart. And so there's a lot of different constraints and different variables that went into designing and then eventually having a vendor produce this cart. So some of the background on this part. First, this cart had to be able to transport over 100 parts. We wanted to have a good quantity for this cart to transport because it has to be going through multiple operations. You want to reduce cycle time, which we'll get to later, and have as many parts as once so you're not unloading and unloading constantly while traveling between operation to operation. So as you can see, I have the different dimensions of this part, and I also have a picture, as you can see in the slide. And one of the biggest things with this part was, it was also one of the biggest things with this part is that it had to go through a cleanliness operation. So that means that this cart had to keep this part clean throughout the entirety of this operation. So one of the biggest things that this cart needed was a solid material to keep this clean and also to not damage it at all. So like I was saying, selecting the material of this cart was important. I have the picture of the original body of this cart. This is what I designed, even though this is not what it's probably going to be produced. So one of the first things we had to do was selecting a fixture to hold these parts in. So in this cart, it actually looks like kind of a lunch tray cart in reality. And we had to have a fixture to hold these parts in. You don't want parts vibrating off and eventually, getting damaged in any sort of way. So finding the right fixture for this was very important. And so during our first design review or design meeting, I got to talk to my head industrial engineer who I work with and a manufacturing engineer who is the head of this part and who has been dealing with the different specifications of this part. And in this design meeting, he told us, this part was of stainless steel. The bellows of these parts can't be touching, and it's important to keep this part in its natural kind of self. And so the fixture we did select was a puck, and this puck was supposed to go on the inside diameter of the part. And so we selected a puck so it's easy able to unload and load parts on and off the tray. And so this puck, though, it couldn't be scratching the inside of this material. You don't want the part getting damaged and then potentially becoming faulty due to the material on a cart. That's a waste. And the next thing was the trays. We're having multiple parts on the tray. This tray has to be able to hold and keep this part clean. So being able to pick a lot of these carts up and efficiently transport it, we had to have a material that was able to hold these parts. And so stainless steel was, I think, our option. We're going to see what our vendor says because this part actually hasn't been purchased yet. But one of the biggest things was having this material be strong enough to hold it. And like I was talking about, it has weight capacity. The part is about 3.5 pounds. It doesn't seem like much to us, but when there's about 30 parts on a tray, man, this material has to be held up and not get affected through multiple uses of the cart. The next thing was reducing cycle time. Of course, it's very important to have cycle time low, man. As industrials engineers, cycle time is one of the biggest focuses of our major and jobs, typically. And you can see I have a picture of the entire cart there. You can see kind of the lunch tray design, and you can see how many parts we have on a tray. We actually have 36 parts. So going to my first point, maximizing capacity for parts. We don't want these parts to touch, but we want to get as many on there as possible with not making this super awkward for the laborer to move around and get to. Reducing wait time. We're buying multiple carts, so we can have them stationed off to the right or to the left, being ready to be loaded and unloaded after operations. And like I said, easy load and unload time. We don't want the operator having to do all these unnecessary movements. We want them to be using both hands to remove parts at the same time and easily and effectively. And then the last thing was ergonomics. We can't have the operator getting damaged during this transition. So we actually had these pucks chamfered, and we had the rest of the cart rounded off. We don't want any sharp edges in case they have unnecessary movement. Another thing we also talked about was keeping these parts separated so they don't touch. And so avoiding pinch grip is an important thing. So we had about an inch clearance between pucks. So, hey, they're able to grab this part efficiently and effectively without having to worry about potentially hurting their fingers. So that is all I have. Like I said, this cart has not been actually produced yet. We're actually in the process of it. I know one of the things that I'm in the cost estimating division of my company, so making sure that this price stays low enough, but also meets the requirements and be able to produce and effectively transport these parts from operation to operation is very important. Thank you for your time.